back, gang. We're talking about frame problems. We finished trusses. This is the next section in the trusses, frames, and machines section. And so I've got a pretty challenging little frame problem to share with you here. Okay, so we have a basketball goal. It's one of those adjustable kind of basketball goals. And look, there I am dunking again and hanging on the rim. What's up? Okay, sorry. The backboard weighs 150 pounds. There's somebody with 200 pounds hanging off the rim. And they say, find the forces on bar BCD. So BCD is here, okay? And the backboard. So what's going on at F? Well, we already know what's going on at D there, right? Okay, so for frame problems, I have written you, there's a recipe right here. Not for sections, but for frames, okay? Okay, so the recipe for frames, you'll notice it's very similar to trusses though, right? Step one, find global equilibrium. It says when possible, sometimes you can't, but I'm telling you, just one little piece of the puzzle, like you can only find like AY, you couldn't find AX or the moment or whatever, but that one little piece is what you need to solve the whole problem. So sometimes we can't find any. Step two, take the frame apart, take all the pieces apart, okay? Draw a free body diagram of each part, but don't draw free body diagram of two force members. Why not two force members? Well, you can't. I mean, it's not like somebody's going to arrest you if you do, but you know, if you draw that, right, and you have F here and F there, what have you proven? That F equals F. Super helpful, right? So two force members, they don't help us any. So we can avoid drawing free body diagrams of two force members because there's no new info there, okay? So step three, of course, solve it. It's a regular old statics problem. This section is all about that free body, okay? Come on. All right, so let's try this out. Step one, can we find global equilibrium for this? So what is global equilibrium at point A? All right, press pause, draw this picture, and then draw those reactions down here. That's not even point A. We'll call that point A, B, C, D, F, G. We'll call it point H, right? This is H. Okay? What are the reactions at point H? Go. Okay, are you back? Here we go. What is that? That is a fixed connection. It's like a cantilevered beam, right? So it has the following reactions. Okay, it would have a H, X, H, Y. And then all of this stuff is trying to rotate it clockwise, right? It's trying to bend it over clockwise. So the ground's going, I got you, dog. And it's like doing that counterclockwise. We'll call that MH, okay? So what is HY, HX, and MH? Well, number one, HX, that's easy. There are no forces in the X direction, so HX is equal to 0. And one of the mistakes that students make is they start thinking about, well, what about that joint? Well, what about that joint? Until you take it apart, there's nothing going on there. So think this is just a big potato here, right? With two forces on it. It's just a big rigid body with two forces on it. That's all it is, okay? So HX equals 0, HY, the up stuff has to equal the down stuff, right? And so going down, I've got 350, so HY, 350, what is that? Pounds, okay? And the last one is MH. How do I get MH? Well, let's just take the moment at H and let's just figure it out right quick. Sum of the moments about point H equals 0. Okay, and what do we have? We have MH, which I drew positive, so MH, okay? All the rest of this is knocked out, so I only have two forces. So I have 150 rotating me negative, so minus 150 times how far away? Let's see, 2.5 plus 0.25. How about 2.75? Okay. And then I've got the 200 over there, and that is, let's see, 2.5 plus 0.25 is 2.75 plus 1.5 is 3.75, 4.25, right? So minus 200 times 4.25, right? Because 1.5 and 2.5 is 4. plus another 0.25, so 4.25. Okay, there we go. Well, that's going to be good, isn't it? So MH, we got that. Let me get my handy-dandy calculator here. So 150 times 2.75 plus 200 times 4.25 equals 1262.5. Okay, MH equals, and that's what? Pounds. Okay, so there's our global equilibrium, right? We've got these two guys, and we got MH. MH is 1262.5 pounds. Oh, pound-feet, sorry. Okay, so let me erase this. We're going to need all the room we can for the next step. All right, the next step is step 2. Blow the frame apart. So if we take this frame apart, how many free body diagrams are we going to have? Do you see any two-force members? What's a two-force member? Pin connected at both ends, no forces in the middle. Okay? EF is a two-force member. AB is a two-force member. So that's going to leave me with this member here, this one here, and the backboard. That's 3 free body diagrams. Let me sketch those for you right quick. Okay? Here's the base. It's all about that. All right, there's one. Then we got this little bar that goes at an angle here. And then we got the backboard. And the backboard has a goal on it, and it's got a couple of tabs on it. Okay? All right, now here comes the critical part. I need you now to push pause and put all the reaction arrows on all 3 of those free body diagrams. And I'll help you a little bit in that, like this guy here has 1, 2, 3 points. This one, of course, has 2 points. And then this guy over here, 2 points, basketball, get it? Okay. This one has 1, something down here, and then what? 1, 2. 1, 2. Okay? All right, push pause, and then when you come back, I'll draw it, and we'll see if we get the same thing. Go. Okay, are you back? Here we go. I got my red pen here with blue on the other end. Let's just do the things that we know, okay? So first, let's put on our givens here, okay? We'll put those on. 200 pounds. 150 pounds. Okay? All right, so what do we have? Two-force member. What do we know about two-force members? Okay, if I pull on this goal, is EF going to be in tension or compression? Well, I think the goal wants to rotate, but EF is pulling it back, so I think he's in tension. So tension members pull on me, and so I get that. And I'll just put that as FEF, okay? That's that little two-force member right there. What's point D? Point D is a pin connection, okay? And I can say that because this guy is not a two-force member, okay? So it's a pin connection. Zrup, zrup. And that's point D. So D, Y, D, X, okay? From that, this goes downhill, that goes downhill, that goes downhill. So dy has to go uphill. This goes to the left, so dx has to go to the, one hop this time, to the right. Okay, now where else is D? D is on the end of this bar, so that point right there is D. Okay, so I'm going to put the other D on here. There we go. dy, dx. And which way do the arrows have to go on that? Remember, the pin at D is not moving, so the sum of the forces on that pin has to be 0. So if they go this way over here, they got to go the opposite way over there. So this one has to go to this way, to the left, and that one's got to go down. Okay? What about this one, point C? Well, that's a pin connection. So CX, CY, and I can leave those arrows for later if I don't know which way they go, right? And then B, again, if I pull on this rim, Do you think A here is being squashed or do you think it's being stretched? I think it's being stretched, right? So if it's being stretched, then it's in tension. And tension members pull. Okay? So this is FAB. Like me. Fabulous. Okay. If that goes down and that goes down, then CY needs to go up. And if that goes to the left, then CX needs to go to the right. Okay? Then I've got one more to go. Now this guy is going to have we already figured this part out, didn't we? He's got an HY, which is equal to 350. Okay? And he's got a moment about H, so there's a moment down here, a burrito force, that's 1262.5 pound-feet, okay? So there's that. What's point A? Hey, there's a two-force member in tension hooked to point A. So guess what you got over here? That is FAB. As a matter of fact, that FAB is the same as that FAB, isn't it? Okay? And then in the middle here, boom, that's joint C right here. We already know what he is. He's a pin connection. CX, CY. And we know these directions. So now I know these directions, right? He's got to go that way and that one's got to go that way. And then finally I got one more at the very top, and at the very top is joint E. This guy was in tension. And so guess what? F, E, F, and that guy are the same. Okay? Did you get it right? And if I solve this now and I get a negative, which would tell me normally that I got one of these forces backwards, I assumed one backwards, I'm going to be really, really shocked because I know that's right. Okay? Because I analyzed the direction, the moments, and everything for the arrow directions on every one. So we should get a positive answer for every single one of these things, okay? And here's the other thing. I want you all to remember this, okay? This little trick where I have CX here and I had CX there. Sometimes you don't know which direction they are and you just have to assume a direction. But listen, if you assume a direction on one of these free bodies, you still have to do the opposite direction on the other free body. If you assume it one direction here and you assume it the same direction there, you will get the wrong answer, okay? So you can guess the wrong direction on one of these, but the other one still has to be the opposite direction, okay? That's important. Muy importante, okay? Okay, so now let's look at these free bodies. The question is, where would you start? Is there one of these free bodies that's standing out to you that I'll be like, I would start there because I can get something if I start there, okay? Is it here? Is there, if this is number, let's just say that this is number 1, this is number 2, and this is number 3. Which one would you start with? Okay, if I take the moment here, I got unknown, no, that doesn't work. I can't do this one, no, that doesn't work at all. If I take the moment there, too many unknowns. What about this guy? Take the moment at D. Ooh, take the moment at D. Yes. And I'm going to get FEF, right? Let's start there, okay? Summing the moment at point D, okay? Now, one thing we need to do here is we need that angle right there, right? We need this angle right there, okay? So this is parallel to that. Do we know anything here? Which one of these triangles do we know? What do we know? Okay, so this distance here is 2.5. So this little triangle that we have right here looks like this. Okay, this is 2.5. Okay, and that's the angle that I want. Then what is this distance right there? Okay, from the ground to there is 10, and then back is what? 9.5. So from the ground to the top up here is 9.5. I don't know how to write that down. 9.5 to the bottom. Okay, And then what is it from the ground to this point? Well, it's 4.5 plus 0.833. Ooh, how much is that? 5.333, right? So 5.333 off of 9.5. Oh, this is complicated, isn't it? 9.5 minus 5.33 equals 4.17. So this little height right here of our triangle is 4.17. Wow. Okay, that's one of the things they like to do is just make the dimensions hard, and then students struggle with what's the dimensions here, okay? I know, you're like, well, that's not fair. You should give us all the dimensions. Well, you have them. Sometimes life isn't fair. So, okay, so this angle and this angle are the same, and that angle is what? 4.17 divided by 2.5 equals 1.668, and then inverse tan of that is 59.06 degrees. All right, so here we go. This guy has two components. He's got one there, and he's got one there. Well, this one's a cha-cha force. Look, watcha. It goes right through point D, doesn't he? So that's the only one I want, okay? And that one rotates me positive. So EF cosine of, what do we say, 59.06, okay, times how far away? So from D up to there, from D up to there is what? 0.5 plus 1.5. How about 2? Goodness gracious. There's a lot of dimensions on this problem. Okay. And then I've got the 150, which rotates me, negative. So minus 150 times not very far away from D, right? Only 0.25 away. And then minus 200 times, how far is the 200 away? 1.5 plus 0.25, so 1.75. Okay, so that's going to give me FEF, isn't it? And let's see what we get. We get 150 times 0.25 plus 200 times 1.75 equals 387.5, and then divide that by 2 equals, and then divide it by the cosine of 59.06. All right, equals, bam, 376.8. And that is pounds. Okay, so that is the force in this little two-force member here. Now, how does that help me? Okay, well, they asked me to find all the forces on the backboard, so now I can get dx and dy, can't I? I can by just doing this, right? The sum of the forces in the x and the sum of the forces in the y. Because I know FEF, I know everything over here, don't I? So the sum of the forces in the x would be dx positive. Okay, what else is in the x? Minus FEF cos 59.06. And I know FEF right there. So minus 376.8 cosine of 59.6, right? All right, sorry, I should have said 0.06 instead of 0.6. And let's just do the equation for the sum of the force in the y, and we get dy minus, let's see, 150 plus 200 is 350 going downhill. And then this component here, which is FEF, which we know, 376.8 sine 59.06. Let's see what we get there. All right, 376.8 times the cosine of 59.06 equals 1937. No way. Hey, let's try that again. All right, so let's calculate that. That would be 376.8 times the cosine of 59.06 equals 193.7. So that's dx. Okay. And then dy is 350 plus 376.8 times the sine of 59.06 equals 673.2. Well, that's, I should have wrote that, equals dy. Okay, so for part number one, the backboard, we got that part knocked out, right? We got FEF, we got dx, and we got dy. Check mark, double check mark, bam, okay? Okay, so we got that figured out. Now, what does that mean? Well, we can take that information up to this free body here, right? Now we know dy. You're 673.2. We know dx, 193.7. And we know FEF, which is way up here, 376.8. Okay. All right. And we know this angle right here is 59.06. We know this angle, right? This angle here is 59.06. All right. We already figured that out. So there's a couple things we can do. I think that this might be the easiest thing to do is, you know, they want to know what's going on bar BCD. Well, where is BCD? Here's BCD, BCD, right? They want to know what's going on in that bar. But what do we not know? We don't know FAB and we don't know CX and CY. Hang on, what's missing on this free body? FAB, CX, CY. So if we solve that free body, we know that free body, we know everything actually. This one has some angles with some distances because the bar's at an angle, and this one's just straight up and down. I think this one's easier, okay? So let's go, let's do it, okay? So let's just, up here, let's sum the moments about, I don't know, where do you want to go? C, let's sum the moments at C, what the heck, okay? And what do we have? Well, who gets knocked out? This guy, bam, gone. That guy rotates me negative. So minus 376.8 times how, times cosine of 59.06 times how far away from C, where is C? C up to E. So what's this distance right here? Oy. I don't know what that distance is. Let's see. We got the, what do we know here? Oh, goodness. This is a tricky part. Okay, I'll tell you what we can do. We know from the ground to the net is 10 feet and then another 1.5. So I know it's 11.5 to here, right? So up to there, 11.5 feet. Right? All right, since we know that's 11.5 feet, don't we know it's 4.17 off of that down to point E, right? So 11.5 on clear, there we go. 11.5 minus 4.17 will give us the distance from here to here of 7.33. Okay, and then what we know from the bottom to point C, we know that distance is 4.5, 5.33. So we know that this distance here is 5.33. So then the distance between these two here is 2 feet. Holy cow. Okay, We had to use our brain on that one. That made my head hurt. Times 2. Okay? All of that for a times 2. And then I've got FAB, which rotates me also negative. So minus FAB times how far away? Okay? So from C, right, over to A is, did I even give you that? No. Oh, golly. We're going to have to find that too. Well, we got it. Well, we don't have it. This is 59.06 degrees, right? So there's a triangle right here. Okay? And what do we know? We know this side over here is 0.833. So then this distance here, which is the adjacent, I must have to use tangent, right? Tan 59.06 is equal to opposite 0.833 divided by that little distance there, right? So 0.833 divided by the tangent of 59.06 is 0.5. This distance is 0.5. Gosh, if you're just giving me that, times 0.5. Okay. And is that it? That can't be it, because a negative and a negative equals 0? No way. Oh, wait a minute. Here's a positive. This is a positive thing, right? So plus 1262.5. Okay? So, goodness gracious. 1262.5 minus 376.8 times 2 times cosine 59.06 equals 875. Goodness gracious, y'all. These distances are killing me, but we got her now, man. We got it, because all we got left is to find CX and CY, right? So that's just sum of the force in the X, sum of the forces in the Y, okay? And in the X, what do we have? Well, in the X direction, I got that guy. 376.8 cos 59.06. No X down here, minus CX. So CX is equal to 376.8 times the cosine of 59.06 equals 193.7. Same as DX. 193.7. All right? Well, duh. We should have had that way back here, right? On this free body, we should have said, hey, up stuff got equal to down stuff. So CX got equal DX. Duh. Okay, so boy, we proved ourselves right on that one, didn't I? There's more than one way to skin a cat, though, isn't there? You know, you can start from the top and go down, or from the little feet and go up. No, I'm just kidding. I have a kitty. I love my kitty. Okay, here we go. In the Y direction, sum of the force in the Y. Could we go down here and do it? Would it be easier? We could do that, you know. We'll do it up here. What the heck? We're already up here. So in the Y direction, I have FAB, which is 875. I've got 350 going uphill. And I've got CY going downhill. And then I got this guy going uphill, which is plus 376.8 sine 59.06. And so the last one, CY, is equal to, drum roll please, 875 plus 350 plus 376.8 sine of 59.06. Oh, this problem is finally over. 1,548. And that is how you do that. We found every single force on that. We found CX, CY, FAB, every single force, okay? That's about a tricky frame problems I could throw at you, you know? If you get this, you can get any of them, okay? How important are these FBDs, y'all? How important? Oh, if you don't get the right FBDs, there's no way you're getting the problem right. There's just no way. You can't do it. All right. Practice those free body diagrams. I know y'all can do this static stuff by now. Practice those free body diagrams, dadgummit. Okay, I'll see you next time, gang.